Hi everyone. Today we'll be talking about complex numbers. Here's the focused learning target for today. Given expressions of the form a plus bi, I will be able to perform operations by combining like terms. So complex numbers are numbers that have a real part and an imaginary part. So first, let's look at the real part. So what are real numbers? Real numbers are numbers that show up in our everyday world. So numbers that show up in our real world. Anything like 1, -7, 14.5, 3/4, or even pi. These are all real numbers. So think about this for a moment. Can we square numbers to get a negative result? Let's try it out. Let's try something like 3 squared. That's 3 times 3, which equals +9. So that's not negative. What if I tried -3 squared? Well, I have -3 times -3, and a negative times a negative is a positive. So I still end up with a positive result. Let's try maybe a decimal. So what about 0.1 squared? 0.1 times 0.1. This would equal 0.01. It's really small, but it's still a positive number. And 0 squared, that'd just be 0. So it seems like there are no numbers that you can square to get a negative result. But what if we step into the imaginary world? So imagine that there is a number where if we square it, we get a negative result. So imagine that there is a number where, I'm just going to use I for imaginary, I squared equals I times I equals -1. Obviously, we've stepped away from the real world, and now we're entering this imaginary world where such a number exists. In this case, I would equal the square root of -1. So this is actually the idea of imaginary numbers. So an imaginary number, 1 squared, gives us a negative result. So again, 1 squared, an imaginary number, gives us a negative result. So let's say I have this imaginary number and I square it, I would get a negative number. And earlier I mentioned the I, which stands for imaginary. So not the Kendrick Lamar song, but imaginary. And I squared equals -1. For this class, or at least this topic, this is the main thing you have to remember. I squared equals -1. Let's say we're asked to simplify parentheses 5i squared. We want to distribute the exponent to both the 5 and the I, so we have 5 squared times I squared. We know that 5 squared is 25, and I squared always equals -1. So our answer would be -25. We've simplified this original exponent. On Edpuzzle, please simplify parentheses 4i squared. So now that we have an idea of real numbers and imaginary numbers, let's look at complex numbers. I like to think of this as somewhere in between the real world and the imaginary world, kind of like when you're waking up, but you're still half asleep and kind of still in your dream. I don't know. So a complex number is a combination of a real number and an imaginary number. It's not called complex because it's like complicated. It's called complex because we're combining a real part and an imaginary part, sort of like a building complex or an apartment complex, where it's just a bunch of buildings combined together. Complex numbers have this general form: a plus bi. So we have this a, which is the real part, and we have the bi, which is the imaginary part. Again, a is the real part and bi is the imaginary part. This is the general form of complex numbers. So here's just a batch of different complex numbers that I wrote out. You can have anything like 2 plus 3i or negative 8 minus 2i. These are all complex numbers. In the upcoming examples, we're going to look at how to perform operations on complex numbers. You'll notice that it's really similar to like adding, subtracting, or multiplying polynomials in the sense that we're still only combining like terms. For this first example, I have 6 plus 7i plus 3 minus 5i. Notice here we have two sets of complex numbers that we want to combine. So what are the real parts? What are the imaginary parts? So we have these two real parts, the 6 and the 3, and we also have the imaginary parts, the 7i and the negative 5i. It's very similar to combining like terms and polynomials. So I combine the real parts. So 6 plus 3 would equal 9. And I also combine the imaginary parts. So I have 7i plus negative 5i, or simply 7i minus 5i. This would simplify to 2i. And so my final answer here is 9 plus 2i. Again, I combine these two sets of complex numbers to get this answer. Let's do another example together. Negative 3 plus 2i plus 8 plus 6i. Notice I have these two real parts and these two imaginary parts. So I'm going to combine like terms. Negative 3 plus 8 is positive 5. And then 2i plus 6i would be 8i. Again, I combined like terms to get my final answer, 5 plus 8i. Please try this next example on Edpuzzle. We have 4 minus 5i plus negative 2 plus 8i. Notice in this example, we are going to subtract the two sets of complex numbers. Similar to subtracting polynomials, the first part stays the same, but we change it into adding format. So negative 5 becomes 5, and positive 6i becomes negative 6i. From here, we're just adding the complex numbers. So we have these two real parts and these two imaginary parts. Let's combine like terms. So 3 plus 5 is 8. And then the imaginary part, negative 4i plus negative 6i. This is the same thing as negative 4i minus 6i, whichever makes more sense to you. And this equals negative 10i. So my final answer here is 8 minus 10i. Try this example on Edpuzzle, and remember to make it into addition format first. So switch the signs in that second set. Multiplying complex numbers is very similar to multiplying polynomials. So here, first, I'm going to distribute this 3 to both the 7 and the negative 2i. So I'm going to have 3 times 7 plus 3 times negative 2i. Next, I'm going to distribute the 5i to both the 7 and the negative 2i. I'm going to have plus 5i times 7 and also plus 5i times negative 2i. Let me add some color to this so it doesn't look as bland and maybe confusing. So I distributed the 3 out. That's these 3's. And I also distributed the 5i out. So right here. Alright, so let's start multiplying all of this together in order. So 3 times 7 is 21. And then 3 times negative 2i is negative 6i. 5i times 7 is 35i. And lastly, 5i times negative 2i is negative 10i squared. Notice right here I have that I squared that I mentioned earlier. What does I squared equal to? So everything else I'm just going to write the same. So let me quickly write this. And then I have this negative 10i squared part. If I rewrite it, this would be negative 10 times negative 1. Again, because I squared equals negative 1. So in total, I'm going to have 21 plus negative 6i plus 35i, and then negative 10 times negative 1 is positive 10. And now, notice here, we can do some decluttering by combining like terms. So 21 and 10 are real numbers, so I can combine those. And I have negative 6i and 35i as imaginary parts. Let's first combine the real parts. 21 plus 10 is 31. And then negative 6i plus 35i is positive 29i. So I multiplied these complex numbers to get the answer 31 plus 29i. Go ahead and pause here once so that you can go through the steps and review any steps that you may have missed earlier. Also, so that negative 10i squared we had earlier, again, this is simply negative 10 times -1, which becomes a +10. Basically, we just switch the signs. The I squared switched the -10 into a +10. Let's look at another example. Here I'm going to distribute the 7 to both the -6 and the +2i. So that's going to be 7 times -6 plus 7 times 2i. And then I'm going to distribute the 5i to both -6 and +2i. So I'm going to have 5i times -6 plus 5i times 2i. Next, let's start multiplying everything out. So 7 times -6 is -42. 7 times 2i is +14i. 5i times -6, this would be plus, so -30i. And lastly, 5i times 2i is +10i squared. Once again, notice here that we have an I squared. So everything else is going to stay the same. So let me just quickly write those down here. And then we're going to have 10 times -1, because again, I squared equals -1. Everything else is still the same. And then 10 times -1 is -10. Next, let's declare. So combining the real parts, -42 plus -10 is -52. And then let's look at the imaginary parts. 14i plus -30i would be -16i. So as my final answer, I get -52 minus 16i. Again, I would recommend pausing once here to go over the steps. Please try this example on Edpuzzle. You are going to multiply these two sets of complex numbers. Let's try this example together. It might look tedious, but don't worry, you know how to do each part. We're just combining the different steps together now. So here, what we're going to do first is multiply the 3 plus 6i and the 2 plus 4i. The -7 plus 5i we'll leave on the side until later. So I'm going to distribute the 3 to both the 2 and the 4i, and the 6i to the 2 and the 4i. So I'll have 3 times 2 plus 3 times 4i. I'll also have plus 6i times 2 plus 6i times 4i. All of it in parentheses. And then remember, I still have the -7 plus 5i on the side. And let's start multiplying each smaller part. So 3 times 2 is 6, plus 3 times 4i is 12i, plus 6i times 2 is 12i, plus 6i times 4i is 24i squared. Then minus 7 plus 5i. I know I'm kind of going quicker here, but remember you can go back whenever you need to. Notice here I have the I squared, which is the same thing as a -1. So if I see I squared, that means I could just switch the sign of the associated number. So in this case, plus 24i squared equals -24. Everything else I just brought down. Next, I'm going to declutter a little bit by combining like terms. So 6 minus 24, the real parts, that's going to be -18. And then 12i plus 12i, the imaginary part, that's going to be 24i. Minus parentheses 7 plus 5i. Notice now we've simplified it to the point where we're just subtracting the two complex numbers. We want to make it into addition format, so the first part stays the same, -18 plus 24i. Instead of a minus, we have a plus, and then the opposites. So 7 becomes -7, and 5i becomes -5i. From here, it's just combining like terms. So we're almost there, guys. We have -18 and -7, the real parts, and 24i and -5i, the imaginary parts. We combine like terms. -18 plus -7 is -25. And 24i minus 5i is positive 19i. So we have our final answer, -25 plus 19i. I know this was a longer problem, but you guys know how to do each step. It's just putting the steps together. Please try this final example on Edpuzzle. Please take your time and double check your work. Today you learned about complex numbers, which involve imaginary numbers, where I squared equals -1. Complex numbers have the form a plus bi, which is a combination of a real part and an imaginary part. We can perform operations on expressions of the form a plus bi by combining like terms. Please remember to submit your notes on Canvas, and see you guys next time.